Hello folks, we come to the miscellaneous exercise chapter 7 and we are taking up the part 4 video now. We'll be taking the 7th question. Let me read the question. Let's see what it says. In the 7th question it says that in the examination question paper it consists of 12 questions which is divided as two parts, part 1 and part 2, containing 7 questions and 5 questions and 7 questions respectively. A student has to attempt 8 questions. Selecting at least 3 questions from each part. In how many ways can he do it? So he has to attempt 8 questions and 3 at least from each part. So that is quite a lot of condition, because we'll have to consider several cases where this is happening. So first case where he selects 3 from part 1, right? So if he selects 3 from part 1, he selects 8, so he selects 5 from part 2, right? Then second time he will select 4 from part 1, then in that case he has to select 4 from part 2. Then third case he selects 5 from part 1, and he can only select that much because there is only 5 questions there. Then in that case he has to select 3 from part 2. These are the cases. So in these cases, what all questions are possible, that once you have got the case, it's easy, because from the number of questions we are choosing, and then total number of ways of doing it. So the case formation is important here. We have these 3 cases, and from these 3 cases we pick up the number of questions that can be chosen. Then we get the answer, add it up, that will give you the answer. Earlier I had told you that when we have cases, the answers that we get in the cases, we have to add it up together to get the final answer. So that's what we'll be doing here. Right. Here three questions, 4 questions, 5 questions from part 1 and 5 questions, 4 questions, 3 questions from part 2 need to be selected to satisfy the conditions. The conditions. So we have number of ways is equal to 5C3 into, from 7 you are choosing 5, 7C5. Case 2, the number of ways is 5C4 and 7C4. Case 3, number of ways is 5C5 and 7C3. Therefore, total number of ways (5 factorial by 3 factorial into 2 factorial into 7 factorial by 5 factorial into 2 factorial plus 5 factorial. 5C4 is 5, we have learned 10. 7 factorial by 4 factorial into 3 factorial, then 5C5 is 1, and 7 factorial by 3 factorial into 4 factorial. So maybe this can get cut. So you have 3, so it will be 4 into 5 into 6 into 7, and then 2 into 2. First case. Second case, 4 factorial cut, so you have 5, 6, 7 and 2 into 3. Then 4 factorial cut, 5 into 6 into 7 and 2 into 3. Let's check out. 6 can cut, 6 can cut, 4 can cut. So what do we have? 6 5s are 30, 21 to 10 plus 25 into 7. Do we know it? Don't think. 7 5s are 35, 3, 7 2s are 14, 175. 175. Then 7 5s are 35. Let's add it up. 5 plus 5, 10, 11, 12, 1, 420 ways of selecting this question. That's how we go about the selections. We can select it in 420 ways. That's about it. Then we go to question number 8. It's a familiar question actually. We have done it in the combination exercise. Determine the number of 5 card combination out of the deck of 52 cards if each selection has to have exactly one king. Exactly same question we did in the combination exercise, but there they asked us to make a selection of 5 card combination where you'll have exactly one ace. Here it's exactly one king. Same way as we did there, we will break this whole problem into two parts. King cards and non-king cards, and how many ways you can do this. So you have to select 5 cards. So out of this 5 card, one is a king and the 4 cards is non-king. And for king you've got 4 choices, you know, and for non-king you've got 48 choices. So you make the choices, that's all, right? Here we have to select one king from 4 king cards and 4 non-king from 48 non-king cards. Therefore, total number of ways of doing it. From 48, you're choosing 4, selecting, and from 4, you're selecting 1. So total number, m ways, n ways, m into n ways. So now let's see how this goes. 48 factorial, 4 factorial, 44 factorial, 4 nc1 is n itself, nc n minus 1, nc1, 4. Yeah, so this is now 44 into 45, 46, 47, 48. And 44 factorial, which is meant to be cut, 2 into 3 into 4, and the 4 there, that can get cut. And then we have the 6, probably 6 8s are 48. Then the huge stretch, let's multiply. 47 into 46, 6 7s are 42, 4, 24, 28, 7 4s are 28, 16, 18. So it is 2, 16, 10, 11, 2 1 6 2, and that has to be multiplied with this 45 into 8 also. 8 5s are 48, 4s are 32, 36. So 36. 6 2s are 12, 36, 37, 9. 6 2s are 12. 3 2s are 6, 6 3s are 18, 4, 3 2s are 6, 2, 13, 18, 7, 7 7 8 3 2 and some zeros here, yeah. This was the answer that we were getting in the ace problem also, exactly the same. So that's about it. In so many ways you can make the cut combination. Next question, the 8th question, it says that, no, it's a 9th question. It says that you have to seat 5 men and 4 women. 5 men and 4 women in such a way that, so that the women occupy even places. How many such arrangements are possible? 5 men and 4 women means automatically they will have 9 seats. 9 seats. And even means this first seat, second seat, third seat, fourth seat, 5 seat, 6, 7, 8, 9. So woman has to occupy only even places. So how many choices are available for women? There are 4 women, 4 choices available. So 4p4 ways, 4 factorial ways. And then once the women are filled, then for men 1, 2, 3, 4, 5 choices available for men, and that also can be filled in 5 ways. So 5 places, 5 ways, 5 places available and 5 people available. So 5 factorial. So let's write here women can sit in 2, 4, 6, 8th position. So 4 places and 4 people are available. For number of ways of doing seating movement is 4p4, which we know is 4 factorial. Also, men occupy places. So 9 places and 9 people. Therefore, number of ways of seating is 5p5, 5 factorial. Now, total number of arrangements into 5 factorial. We know those numbers. I'll just put it across. This is 2, 3, 4, so 24. This is 24 and this is 120. So let's check what it is. 24 into 12. 12 fours are 48. 24, 28. 2880. That many ways they can be seated. That's about this problem. There are 2 more problems left that we come in the next part. Thank you.